Hello and welcome to rchacker.com. In this video I'm going to explain my KK2 Arduino code and I'll go through the source code and explain it step by step and how it all works and stuff. If you haven't already seen it, you might want to watch this video here. It's the video where I basically explain explain it how it works on the KK2 itself. So you can just click on here if you haven't seen that video already. If not, let's move on. So I'll put my ugly mug in here, and here we go. Okay, so I've opened up my test code in Arduino. Basically, I start out. You're going to have to include this library here, which is a modification on the LCD code, which I got. I think bits came from the OpenAero project, and other bits came from a forum post I found by Captain Cook, the writer of the builder and the writer of the KK2. So I'll explain that library later. For now, we'll just move on. Now, basically, these definitions here. Any program you want to write, you're going to have to include these. So I've made them all up here, and basically I've got each of the pins here. I've got the input pins and the output pins, which of course can be used as inputs or outputs. And next to them here you can see I've explained I've got exactly which pin it is on the ATmega324. So you can see you've got one of the TX1 and RX1. That's one of the second serial port on the ATmega324, and you've got one transmit pin on the first serial port exposed. The other one's not available. Okay, that's actually being used on the LCD. You got a timer there as well. And some of these are more advanced functions, so I might just skip down. You know, you can read the comments yourself and have a look. There's a pin exposed where you can hook up an external crystal if you like for some sort of external clock. That's getting a bit more advanced. That's more AVR programming than Arduino programming. You've got the JTAG interfaces exposed. I've never used JTAG, but I've never really found the need to step through code that's running on an MCU. I'm sort of the belief if you've written the code well enough to start with, you know, all you need is a few serial prints and stuff like that, so you can figure out what's going on, and you know the proper use of LEDs and flashing them at the right time can quite often help you for any debugging. There's an I2C is available, so you've got the potential here to hook up all sorts of I2C or I2C, all sorts of I2C devices, and there's loads of devices out there. I haven't tested this yet, but I see no reason for that to work. These ones here are the buttons. Obviously, you can only use them as inputs. Now, you need to enable the internal pull-ups when using these as inputs. Okay, so basically, by default, they're floating, and when you press the button, they go to ground. Moving on, you've also got the buzzer there as well. Now, this is actually hooked up to one of the clock pins. It's probably a more advanced thing, but you can adjust the clock output with the system prescaler. You'll have to look at the ATmega324 datasheet to actually see how to do that. There might be some Arduino libraries out there which you could add, and that would do that, but I'm not sure if my hack for the Arduino, how do I say this? I'm not sure if the hack that I've made to make Arduino work with the KK2 actually works. So I'll mark that as not tested as well. Alright, these here, I had these in to start with, but the LCD library takes care of them. You'd only need to uncomment them if you wanted to actually write your own LCD library, which, man, it's only for the people who are really keen, I reckon. Moving on. Okay, these are the analog pins that are available. I've written here, analog reads must be done using their channels. Specifying digital pin numbers will not work in this case. That's just, I'll show you later, but basically in normal Arduino code you can actually do an analog read and then specify the digital pin, or you can also specify the analog channel, and in this case one of them isn't used and the other 7 here I've used here. Okay, so basically you got the battery, that's got a voltage divider, so you can put, say, I think it's up to a 3-cell LiPo on there to measure the battery voltage. And you've got the gyro, roll, yaw and pitch, and you've got the accelerometer, X, Y and Z. Now you've noticed here that I've used const byte when declaring these. Now the reason I've done that, so many people, and I see it a lot all over the place, will use hash define to do the same thing. Okay. Now the problem with that is basically you've got the preprocessor and the compiler. Now the preprocessor goes through first and does all these hash define things and takes this hash include and expands the code from that library in here before it sends it to the compiler. Now if you use it as a hash define, the compiler has no way to pick up any errors if you got the say the variables names wrong or something like that, and you can get some very hard to debug errors if, say, the hash define, it basically just replaces text. So if it finds in1 anywhere here, even if it's part of another variable like in1 underscore special or something, it will replace that in1 with a 0, so you'll have 0 underscore special, and then that gets passed on to the compiler and you'll get all sorts of weird errors. And believe me, like in the industry, sometimes chasing down these errors is a real pain in the ass. So it comes from the railway industry. Part of our coding practices was we always use these const byte declarations, and that way the compiler can pick up any errors, and just much more helpful and much more maintainable. You might think that, oh, this will use up more RAM on the MCU. It doesn't. So the compiler does the proper optimizations and it's not a problem. It uses exactly the same amount of RAM. Alright, I diverged a bit there, so moving on. I've got a couple of constants here just so I can adjust them easily. They're just to do with the debouncing code, which I'll get to. Alright, now the Arduino setup code. Okay, you've got here basically we're declaring our pins as inputs or outputs. Red LED is obviously, we want that as an output, and our gyros we want to declare as inputs. Okay, that's for the analog reads. Moving down, buttons as inputs, and here is where I'm actually enabling the internal pull-up. It's not immediately obvious in the way Arduino is written, but if you do a digital write to a pin that's declared as an input, that will enable the internal pull-up on that pin. So that's why I've done that here. So I've done that on all the 4 buttons. Now this is the analog reference external. Now the way that Rolf has wired up this board, if it uses an external reference for the outputs of the accelerometer and the to measure the outputs of the accelerometer and the gyros. So if you don't put this in, basically what happens whenever you go to do an analog read, the whole MCU resets because it actually creates a short in the circuitry. And that took quite a while to figure out what the hell was going on there. But yeah, I worked it out, and you need to do analog reference external, so have that declaration in there. Important. Cool. Alright, now this here, these are the routines for handling the LCD. So this is just my initial setup for the LCD. Basically we declare, we say we want to start writing with a 5x7 font. We set the brightness of the LCD screen to 12, And sorry, I'm clicking on the keyboard there, it's probably making a hell of a noise. Alright, moving on. Now, these are just drawstrings. I've got Arduino on the KK2, Test Suite version 1, Mark G. Press any key. And then I've got this function called write logo. Now, I actually modified the library so I could write my own logo, and I took this idea from the OpenAero project. Now, I'll just minimize this, and we'll just go to the library itself. So this is the main file for the LCD library. Okay, now when I do a write logo, this buffer, when it's declared originally, you can see all this data here. This is actually the my RC Hacker logo. Okay, and I created this using a little program called LCD Assistant. Okay, and you basically, this is a bump file, BMP file. Okay, so you put your image in your favorite image editor. I use GIMP in this case, and it needs to be, it's not actually upside down, it's mirrored sort of vertically, I guess you could say. Yeah, it's mirrored vertically, and so you get whatever image you want to display there, and then you go save output, and that'll save it into a little header file, and then you can cut and paste your values straight into here, so you should be able to get an image. Okay, I'll come back to this. Back to my code here. So that's what this write logo does here. Now, if you want to write extra stuff on there before you do a write logo, you got to do it beforehand and then write logo, and that writes what's in the buffer to the LCD screen. Okay, so it's pretty important. If you write anything after here, it won't come up again until you do a refresh, and then by then it's all garbled up. So you only get one shot of this at the start of the screen, but that's all it is. It's just a flash screen for your software. Alright, moving on. Now the first thing we do on the setup, this is just a pause. That'll pause for 1 second, standard Arduino stuff, and then I've got a little infinite loop here. While it's true, and until we get any sort of input from the buttons, until any of these come out as, you'll remember these, when you press them they go to low, so that's why I've got a little knot in there on each of these, and then a bunch of ORs. So once I press any button, it will break out of this code and then continue on into the main loop. I'll just skip down to the main loop because that's down the bottom. Here's the main loop. Now basically we're going through each of, sorry, traffic and beeping there. So basically we're going through each of the, in these cases, this whole program is test program, so these are the test cases. So now I'll just go back and we'll explain these. Now basically each of these test cases, they've all got their own handling for go to the next case, and then it'll just cycle through. So once you're here, it'll forever go around. It's in this case. So let's scroll back up and look at okay, the first thing I've got here is the button pressed code, which, excuse me a sec. This is just a little bit of handling code for the button presses to navigate through the menus. Okay, so let's see if I can demonstrate that. Let's go back to our other video. Yeah, here we go. So you can see here, see as I'm pressing the button there, it shows next and everything, and it goes to the next test case. Yeah. So that's this code here. So if we got if not digital read button 4. So if digital read is 0, basically we do a short delay. That's just for our debounce, okay, and then we go into another loop. If it's still pressed down, okay, then we go into this infinite loop here. So if it's still pressed down, and while it is still pressed down, do this. So right now it's in a little infinite loop, and it's displaying, it's clearing the buffer and setting the font, and it's displaying next, and it's making that red LED high. So as long as you're holding down the button, this little loop is going to go round and round really fast, okay? And then once you release it, this becomes false, so it drops out of the loop, and we get to we've just got a delay microseconds. That's for the debounce of it lifting up, and we switch the red LED low, and basically I've got here a return 1, which means yes, button 4 pressed happened, and otherwise, if no button was pressed, we get a return 0. Okay, so moving on. Now these functions are a bit out of order from what was in the loop function, but that of course doesn't matter. Okay, so probably the simplest case here, simplest test case, is the fonts one. Go back to our video. There it is. Okay, so let's pause this and we'll go back to the fonts. There we go. Okay, so this is our fonts test routine. So I've got a little delay at each one of these. Actually, I don't think that's even necessary anymore. Yeah, I've deleted them in all the other ones, so actually that's just one that I left behind, so you can actually comment that out, and because of all that code here, that's all the button pressing is handled now. So that was my initial pretty ugly code for doing the button presses and stuff, and it made it quite slow. With that code above, with the more code, it actually made the button pressing quite a lot more responsive and faster, so cycling through the modes. Anyway, so I set the brightness to start with. I know it was already set at the start, but one of the other routines messes around with the brightness, so at the start of each routine I was setting the brightness again. And then I've got a little infinite loop here. We clear the buffer, set the brightness again, so obviously that's redundant, and moving on, set the font to 12 by 16, and then we write the font, and I've written the font in text 12 by 16, and it's at position 0, 0. And you can see here that's actually measured from the top left hand corner of the font, and then it's written like that. Okay, so it sort of goes across like that there. Moving on, change font to font 12 by 24 numbers, draw string. Now these, I've just done this for ease of calculations and placing them on the screen, and this is calculated before. This is calculated by the compiler. It's not done in real time or anything like that. So there's no loss of performance there with those calculations, but it makes it easier just to place stuff on the screen. Like, they've got good reason. So drawstring 12, drawstring 24. You'll notice that it's, the function is actually a drawstring p, and that indicates where the string is actually stored. So sorry, dogs are barking at something. Alright, it's nothing. So moving on, where were we? Yeah, so we got a drawstring p, and this function here, I'm pretty sure it means store it in program memory. I could be wrong there. I've got to look into it. But for now, if you want to draw a string, do it like this. Yeah, and that'll store it. I think it stores it in program memory on the MCU there. Now keep in mind, the more text you have, the more memory, more RAM it's going to take up on your MCU. So there is a limited amount of text you can display, and if you really want to get fancy, you've got to start reading it from the EEPROM or external memory or something if you've got it attached. I don't think we're using the EEPROM in this case. So obviously this is just setting more fonts, drawing a single character to get the dot in the middle there, and then of course every one of these routines is going to have this draw string next, and that's for my next button, which is handled by the button 4 routine, the button 4 pressed routine as before. So if we get a button 4 pressed, we return. So that basically means we return to the main loop out of this font function. Alright, this bit of code here, I was playing around with draw coordinates just to demonstrate where the coordinates are on the screen, but I was declaring strings and stuff, and there was a memory leak in there, and it actually started corrupting what was written on the screen. So I actually, yeah, I just put that in the too hard basket. It's not an issue for me right now. For most simple things, you're probably not going to want it. But basically, I had a function which would, you give it the coordinates, and it would write a little string with what the coordinates were on the screen. So then I could do this and then just figure it out. Now, it works, but it will actually, as it goes through and starts corrupting the RAM in the MCU, eventually the MCU can go into a runaway state, or it depends if the fuses are set, if it'll run a watchdog or anything like that, and basically it crashes. So it'll run a couple of times, and then what's on the LCD will get a bit garbled, and then it starts writing to the wrong places and then over the program code, and you can do all sorts of things. Who knows what it could do. It could start enabling outputs on the pins and stuff like that. It can even mess up the fuses on your MCU. The chances are slim, but it can happen. Mess up the fuses on your MCU and actually brick your board. So that's a more advanced topic, but just be aware that that sort of thing can happen. Alright. Moving on, the analog function. Let's just find it here. I think that was one of the last ones I looked at. Yeah, there we go. So, analog read. Same deal. Setting the brightness. I've got this aRead variable here. And clear the buffer. We write analog read at the top there. And then I've got a short delay here of 10 microseconds. If you're actually, I think it's somewhere in the documentation, if you got to let these analog the analog system settle a bit. If you just do repeated analog reads, I think you can get some false values there. Could be wrong there. That's just from memory, but it's just a little safeguard. In this case, it doesn't matter a rat's ass either way. Like whether that the length of that delay, I think that's about the minimum. It's not very long anyway. So I'm doing the analog read here and converting it to a string, and then I'm just putting that into this string, just turns it into a character array, and then I can draw the gyro roll, which is the text you see up here, and then I actually draw what is in that string. That str was declared much further up. Like I think I declared it as a global variable at the start, in between the setup and stuff. So then you've got obviously the other gyros. So they're just basically the same code of cut and paste there. Not the best coding style, but yeah, it works. And the last one is the analog read one for the battery. Okay, and then we've got our little draw the next and do a refresh on the LCD. These clear buffer and refresh. When you do the refresh, that's when everything gets written to the screen. Okay, and then everything else that happens in here, it doesn't really matter what order it happens or whatever, as it all gets written to the screen when you do a refresh. and then we do our button handling routine. Okay. I think the buttons was one of the earlier ones. There we go. So the button code here, again, you'll find whenever you're dealing with having an LCD interface, you're going to get a lot of code that's showing the state of the interface. It's actually probably what most of the code in this thing is actually doing. Anyway, basically I'm just doing a digital read on each of the buttons and then printing the values out. I'm only doing the first three because the next button is obviously you need that to go to the next state, and it tells you the state of each button. I actually didn't try it in the video to see whether this code will handle multiple presses at a time. Maybe that's an exercise you can try yourself. It should do, because they're each on different digital outputs. So that code there, you know, it's good for multiple button presses at a time. So you could actually write a user interface that would need, you know, say a style of shift select or something like that. It's getting pretty advanced, but because they're all on separate digital pins, you know, you can do that. Alright, moving on. LEDs. So excuse a motorbike going past. So let's move on up here. Do I really need to demonstrate it? Okay, this is the one here. So let's go where it said 13. Ah, that's too hard. Doesn't matter. Alright, so this is the digital out routine, and basically, oh, I forget, what was that offset for? Alright, that was just for, probably don't even need that. That was just for positioning the text on there. Yep. So that's actually irrelevant. I could probably delete that because it's 0, and then delete these offsets here. Yeah, I think that's the only instance of that offset there. So what I've got here is a for loop which goes from 0 up to 13. It drops out before it gets to 14. So it's doing all the digital outputs. I got 1, 2, 3, 4, 5 on that side, and then another 8, so that's 13, and then the LED, which is 14. And I didn't, in this case, test the buzzer pin as well, but that's also you can use that as an I/O pin as well. So what are we doing? We're clearing the buffer, we're writing our big digital out on the top. We're declaring a string of I, so that's basically the number it's up to in the loop, and then we're converting that to a character array, so then we can print it to the LCD. Setting the font, and that's actually where we write the number. So this is sort of the digital write. I'll just, finger, stop it. So this is code here for the digital write. That writes that section there, and then we write the number of, oh sorry, there was a good reason for the offset. That was just to handle, well, you had 2 characters on the number or 1 character, so it would move this back and forth. So I'll just undo that. There we go. I should probably comment that, and I should probably put just for, well, whatever, because I didn't, even though I wrote this fairly recently, I forgot what that was. So that's a classic case, a nice little comment just explaining what this offset is for, because it wasn't immediately offset. So yeah, if I is greater than 9, which means 2 digit, it's going to move the offset a bit, so it's going to move this last bit of text over a little bit so it makes room. Okay, and then we've got our next code there. And then here we've got, depending where we are in the loop, it's going to write that pin high. So, you know, it sequentially goes through. Now, this extra bit of code here, because I wanted each pin to stay on at a certain amount of time, in this case it was 100 multiplied by 5. Yeah, it was 100 multiplied by 5, which was 500 milliseconds. I wanted it to actually be, while the LED was on, I just didn't want to put a delay there and then detect whether the button was pressed, because if you're trying to press the button when when just a normal delay is there, it's not going to do anything. So it's only going to do it in bits, so it's going to be quite hard to get to the next state. That's why I've got this loop here, and then it's just got a shorter delay. So I've got 5 multiplied by 500, so I think each of these stays on for half a second and it just cycles through. And each time as well, afterwards, after we've paused and we've had that lit up for half a second, I write it low again. And then of course you go back up to the for loop, it's incremented, your I is incremented, and on you go. And of course the button 4 pressed, if that returns true, we return, which drops us right out of this LED routine. Okay, now let's move on to the contrast one. Where is it? There we go. So we've got 35 different levels here, okay? So I just wanted to step through each level, and each time I write the set brightness at the top. We've got our string, yeah. We'll get our string, we convert our number here into a string and then into a character array, so it's easier to print out when we do this drawString here. Okay, you'll notice here also, this drawString doesn't have a P on it, and that's because it's doing it from a variable. So I'd say it's because it's rather than program code, this is coming from the RAM. Okay, this string's stored in RAM, so it prints it from RAM, and the other one, the drawString P, will take it from the program code, so that is stored in program code. Okay, now moving on, we can do our set brightness to the value I, and set our font and do our next thing and hit our refresh. And again, just like above, I actually commented this one, gives us a delay of 250 milliseconds while still detecting button presses. Yeah, okay, so it just loops through quickly and continually checks if the button's pressed and does a delay 5. So 5 multiplied by 50 is 250 milliseconds. And of course, once you press the button, it drops out of the contrast routine. Time function, I don't have to show it up there. Now, pretty much, this is just one I did to test the clock and make sure that I had everything working properly. As you know, most Arduinos run at 16 megahertz, and the KK2 runs at 20 megahertz. It's got a 20 megahertz crystal there. So this routine, I write the text first and I write it once, and then we go into the loop here, and it's basically a little bit of highlight code. If millis modulo 1000, which means a modulo just gives you the remainder, I think. So if that's equal to 1, or if that is equal to anything but 0, we write a low, okay, and then if it is equal to 0, we write it high, okay, and in there we do our delay for 100 milliseconds. Okay, and then we've got our if button pressed return 4. Now you could probably put test for the button press within this delay loop as well if you wanted to keep your responsiveness, but that worked alright. Like 100 milliseconds is not too noticeable. Alright, and moving down, we've got the loop here, so that's pretty much it. I'm just going to take a break now, and then I'll go through and we'll just run over the library and how that's structured and stuff. So yeah, I'm back. Now, moving on, I was going to explain the library. Okay, so this is probably the key to getting the LCD code to work. Now, if we look here, we can see here where the library is located. It's in my documents, Arduino, libraries, and then it's under KK2 LCD. Okay, that name there has to be the same as what your main header file is, okay, to make it work. I'm pretty sure that's the way it works. Now, if you're on Windows, I'd say you'd have an Arduino directory under My Documents, and then you've got to make a libraries directory if it's not already there, and then you'd stick it again in your you stick the library here. Now that'll be on my website for download. Okay, so that all this will be on the website for download. So this is the library itself. Basically, this header file, I just made this rather than having all these hash includes in the start of your code. I've just put them here. Okay, so that just consolidates everything to make it nice and friendly for Arduino. And then everything in the library. Now this is if you're using AVR Studio or something, it should be compatible with that as well. But the whole purpose here is to get it working with Arduino for beginners to use, pretty much. Yeah. So this one's a whole lot of type defines, type defs. Really, I don't know what that one does. Don't worry about it. Your header file for the LCD library. The ST7565 is actually the model number for the LCD module on this thing, in case you're wondering. So here we've got all the pin definitions. These are the pin definitions for the LCD. Actually, they're commented out there, so I can't remember why I did that, but it was just part of getting it to work. So these are the commands. I think they use there's some sort of serial commands to make the LCD do what it does, and it's actually quite complex. Okay, these are all the prototypes for the functions for doing various drawing, initialization, etc., etc. Logo.h. Actually, I'm not sure if I'm using that or if I moved that into the main code. So, actually, no, this is the one that was generated by LCD Assistant, and then I cut and paste all these numbers into the main LCD library code to make it work. IO config. Now, this just defines all the pins basically. Now I've commented out large sections of these because I'm doing it in Arduino instead. Like this is more AVR stuff, so it's got all the RX pitch and all that sort of thing. You'll note they're using the hash define method, which, as I mentioned before, I don't like. You should be using what is it? Constants. But anyway, some of these are macros as well. Okay, so they actually they do a text swap, right, to put these in here, and these sort of macros and stuff, I don't really like that coding style. I could probably comment out more of these actually. It's a bit hard to see there. I'll open it up in Xcode instead. Alright, here's that same file in Xcode. So I have commented out a whole lot of these. I could probably comment out these ones as well, okay? Because I'm not using these as well. So I might actually try that out and comment out the whole lot. Now, I know it's a mess here, but basically my main goal was to get it working. So, and once I got this library working under Arduino, I didn't really go much further with it. This is just declarations for the fonts, okay. Written by Kevin Townsend up there, so credits where credits are deserved. And these are the definitions for the numbers and stuff. You could probably use that LCD Assistant program to create your own font sets, but these ones here are already done for you. Okay, so it's no mean task, and actually these fonts take up probably a great portion of your the RAM on your MCU. Okay, there's plenty in there. There's 32 kilobytes of the stuff, but you know, these ones here take up quite an amount of your program memory. Give me a second. I've just got to go and check on something. Right, I'm back. Now, what are we up to? We're just going over the fonts. Yep. Now, the last one that's worth mention, of course, is, well, the main file that pretty much makes up the library. Blah, blah, blah. K. Townsend again. So I should... I'll thank him here. So yeah, thanks for making this code. It's the license here is a BSD license. So God, I'm not a lawyer, but you know I'm pretty sure I'm okay to use this. I've put a Creative Commons license on my test code, so you're free to do with that whatever you want, as long as you say thanks. It'll make me happy. Yeah. All right, moving on. You got various includes here. This is more AVR stuff. When you're using Arduino, a lot of this stuff is hidden away. Like what Arduino does, it takes you from the C code level and then puts another level of abstraction. There's a hell of a lot of code behind Arduino to make it nice and simple. You lose a few features, of course, but most people, they just want to write to digital pins in and out and stuff. And then you've got all the other libraries which will do more complex stuff. Okay, here is my IRC Hacker logo, as I explained before. This is the write buffer function, which actually does the writing of all the what's in memory to the LCD. Send byte. I don't know what that one does, but moving on. ST7565 draw character, so that'll draw a single character on the screen. It is a bit messed up. Like they've got all these comments like public methods, blah blah blah, and it looks like stuff left over from the IDE that Townsend was using at the time. God damn, these trucks out here have got such noisy exhaust brakes. You would not believe it. Get an Aussie road train and then just take the mufflers off. They're unreal. Moving on. Now, obviously, there's a lot of commands and stuff, and this is all handling the I/O with the LCD. As you can see, there's quite a lot that goes on there. Clear screen, clear buffer, refresh. So basically, clear buffer and then refresh are the ones you need to do before, and then when you're done drawing all your pixels and stuff. I didn't use this one, draw pixel. Okay, that'll draw an individual pixel on the screen. Okay, and you could use that and then build more functions to do stuff like draw lines and circles and stuff. And if you want some examples of that, have a look in the OpenAero code, because he's got code in there for drawing lines and circles and stuff like that. It's worth a look. A clear pixel, yeah, obviously clears a pixel. Well, he's actually got some nice comments and stuff in here. So draw a string. He's got the two types of draw string. I don't know if he's explained why in there. No, he hasn't. And I've got a feeling this stuff is auto-generated. You know, he's got brief and encode and all that sort of stuff. And, you know, this code's free, but hey, the same thing. I think he's got it working and then published the stuff. Oh yeah, there's a draw line in there, and he's making use of the draw pixel. Okay, and he's got a draw rectangle as well. It's just for the example, have a look in OpenAero for draw circle. And here, this is the only modification I did, and this is just the right logo. Okay, so that just writes. It'll only happen once because I've initialized the buffer to all the values of, you know, what's in there. So I'm not actually using up any more memory. Like this has been reserved for the LCD buffer, okay, and I've just initialized it with my RC Hacker logo. So the first time you turn it on, I got this right logo routine here. Now I had to just change this line here to make it print properly, otherwise kind of hard to describe. It'd be divided up into, I think it was 64 divided by 8 sections, and they'd sort of be, each of the 8 sections would be upside down, so the whole image looked garbled. But you know, I figured that out. That was just a matter of, instead of 7 minus p, putting p. How it worked. So yeah, that's a little overview of the library and what's in there. It's not the most the prettiest looking code. I didn't write it either, but it's just what I found in my my research to get the LCD code going. And I certainly, you know, this is the beauty of open source. Okay, if it wasn't for open source code, and you know, I'd be having to write this crap myself to get it all working, and that's, to be fair, like, it's not the sort of code I want to be writing. It's quite monotonous, and you know, the guy has done a brilliant job. So why bother reinventing the wheel? Like, you may as well focus on actually being creative. So yeah, and getting this working with Arduino was part of the whole goal of doing that. So yeah. So yeah, now you're familiar with all the actual test code and stuff. The next thing you want to probably do is upload it to your KK2 and try it out. Now, it does involve hacking the IDE. There's a few files you've got to change within Arduino, but it's not difficult, and I'm going to show you in another video. First, I'll just demonstrate and prove that this actually uploads to the KK2. So we'll just verify this. Remember, I made a few changes. Okay, whoops. So I got an error there with this URL. That's better. Let's check it again. Set brightness. Okay, I've accidentally deleted one of my comment things there. Compile. TikTok. Done. And you can see the size of it there. We're using 12 kilobytes of the available 30 kilobyte maximum. Actually, this 30 kilobyte maximum, you've actually got room for a bit more. So probably another 2 kilobytes, because as I'll endeavour to make sure it is correct, but because I'm not using the Arduino bootloader, we can make use of all of the RAM. So to do the programming, don't know if that's going to focus on there. we're using a to do the programming. I'm using the AVR USB ASP programmer. Sorry, not AVR. This is made by another guy, sort of a homebrew programmer, which has become very popular. They're about $6 on Hobby King. So when you do, if you do buy one of these, it's way overexposed there. If you do get one of these KK2s, you need to get one of these as well. And you'll find these are very useful in programming a whole lot of things. Just this little bit here, this is just what I use for programming my ESCs. I've got another stuff on my website about that. So that is yeah, I think we can get the idea. Now I'll try and hold this up there. Now, rather than, this has still got the KK2 software. Now, normally you would upload using this button here, but in our case, because we're not using the bootloader on the Arduino, we've got to go upload using programmer. You actually need to go Tools, Programmer, use and select the USB ASP first, okay, and then use this upload using programmer. Now hopefully this will work. I just got to get my hands off here because they're very sensitive to static. And let's see if that will work. You can see it down here. It's verifying the flash data now, and done. Oh, I've got that upside down there. So there's that code that we just went through, and yep, that's it. So I hope you find this useful. I'll put some more videos up. I'll put a video up to explain the hardware on this in detail, so you got all your chips and stuff in there. So I'll endeavour to make a video that's got all the hardware on that one in detail, and I'll also do another video. Say we're going to put it, give me something nice to look at. Yeah, so we'll aim for click on this square here to go to the next video that'll explain how to actually modify the IDE code to put onto to set Arduino up so it all works with the KK2. So click here for the hardware in detail, a bit of a teardown and stuff, well, not much of a teardown, and click here to see how to modify your Arduino IDE so you can do Arduino programs on the KK2. So thanks for watching, and if you have enjoyed this, please subscribe.